Section 5.3 is on page 205. Talks about series solutions near an ordinary point, part 1. We're going to do the majority of this section for this video and one problem left for the next video. That's going to really work well with 5.4, 5.5, and 5.2. So, if x sub 0 is an ordinary point of a differential equation 1, which is right there. Again, make sure that is a 1, where p of x and q of x are analytic at x sub 0, then the general solution of equation 1 is given by y equals, since this is a second order, you get two solutions, where a sub 0 and a sub 1 are arbitrary and y1 and y2 are two power series solution of that are analytic at x sub 0 as well. The solution y1 and y2 form a fundamental set of solutions. Further, the radius of convergence for each of the series solutions is at least as large as the minimum of the radii of the convergence from P1 and P2. This kind of like domain. If you have domain and there's a restriction, you take the smallest restriction possible to satisfy all cases. So the deal here is we're going to start today with one portion of it, and in the next video the problem I'm leaving out is really the series solution. For now, we want to figure out two things. One, how to find initial conditions, and two, how to figure out the biggest radius of convergence. So on page 209, 1 through 3, they only have one even. I'm going to give you another example. They say, figure out what the initial condition is for the second derivative, third derivative, and fourth derivative. Assume that y equal phi of x, which means if I take y of 1, that phi 1, which is 2, and if I take y prime of 1, that's phi prime of 1, and that happens to be a 0. And here's the differential equation. If I start off by taking a derivative to get, actually the second derivative I don't need to do much, it's really x squared. Y double prime is simply phi double prime because that's y equal phi of x, plus 1 plus x times phi prime, plus 3 times natural log of x times phi equals 0. And if I substitute, and it's in this class it's always at 1, so evaluated at x equal 1, I'm looking at 1 squared. Let me keep them in colors so we could separate between those. So 1 squared times phi double prime of 1, plus if I put a 1 in there, that becomes 2 phi prime of 1, plus 3, a 1 in there will give me a 0. So this is phi double prime of 1 plus twice, and this is a 0, plus 0 equals 0. That indicates that phi double prime of 1 is actually 0. So that gives me what I need, which is really y double prime of 1. That is phi double prime of 1, and that is a 0. Now to find the next, I would take a derivative. To take a derivative, I need to use the product rule. That's going to be, and it should be out of this now. Now I'm looking at 2x times phi double prime plus x squared times phi triple prime plus product rule again, 1 times phi prime plus 1 plus x times phi double prime plus 3 times 1 over x times y times phi plus natural log of x times phi prime, and that's still equal to 0. Evaluate it at x equal 1. I'm looking at 2, and phi double prime of x, I just got it at 1 to be a 0, plus 1 squared phi triple prime, plus 1 times, and phi prime is also a 0, a 1 in there that will get me a 2, times a 0 again, plus 3 times 1 over 1, and phi is a 2, plus a 1 in there will give me a 0 equals 0. That indicates that I'm looking at phi double prime, phi triple prime, that's a 0, that's a 0, that's a 0, plus 6 equal a 0. That means phi triple prime at 1 is actually a negative 6. So y triple prime of 1 is phi triple prime of 1, and that is a negative 6. So I got the third derivative. They want us to find one more. And let me take a derivative of this. And that's how it works. Not that bad. So if I take, again, the derivative of that, I'll get 2 times phi double prime plus 2x times phi triple prime plus 2x times phi triple prime plus x squared times the fourth derivative plus, that is just phi double prime, product rule, 1 times phi triple prime plus 1 plus x times phi double prime plus 3 times product rule, negative 1 over x squared times phi plus 1 over x phi prime plus 1 over x phi prime plus natural log of x phi double prime. So you just have to be patient with this a bit. It's not that bad. Evaluate it again at x equals 0. And let's see how this works. So I'm really looking at 2 times, and here they are. Phi double prime is a 0, plus 2 times 1, and phi triple prime is a negative 6, plus 2 times 1 times a negative 6, 1 squared. The fourth derivative is really what I'm looking for. Phi double prime would be 0. Phi triple prime is a negative 6. Plus 2 times a negative 6 again, plus 3 into, this is a negative 1 times 2 plus 0 plus 0, and natural log of 1 is 0. Hopefully we don't make a mistake. That's gone. So we have a negative 12 minus 12 plus the fourth derivative evaluated at 1 minus 6 minus 12 and a minus 6 equals 0. Let me just double check the calculations. Okay, I found a small mistake right there. When I took the derivative of this, that should have been 1 times phi double prime and 1 plus x times phi triple prime. That makes this right here a 0 as well. So I need to get rid of one of those 6's. Okay, now it should match. And if I look at this, this would indicate that the fourth derivative evaluated at 1, so the fourth derivative evaluated at 1 is, and that should be a what? 12, 24, 36, 42. And that's how you really find additional initial conditions, just by using what's given. And since there's only one example, I decided to give you another example and change the problem a bit, something to match your homework. And the same deal happened here. I'm going to do the same thing. let y equal y double prime second order sine of x times y prime plus cosine of x times y, and I'm giving you the initial. So y of 0 is actually phi of 0, and that is a 0, and y prime of 0 is phi prime of 0, and that's a 1. So if I really want to start to find the third derivative, well, here it is. This is actually, if I just rewrite it, this is actually phi double prime plus the sine of x times phi prime cosine of x. This author likes phi a lot. We could have used a different variable. So if I take phi double prime of 1 plus phi double prime of 0, we're evaluating everything at 0 in this case. Those don't change in this class. So don't change for the most part. Sine of 0 is 0. Phi prime is a 1. Plus cosine of 0 is 1. Phi is a 0. So that gives us that phi double prime of 0 is 0, which means y double prime of 0 is phi double prime of 0, which is a 0. Now if I take a derivative of this, that would give me phi triple prime plus the product rule, cosine of x times phi prime plus sine of x times phi double prime minus sine of x phi plus cosine of x phi prime equals 0, and again evaluated at x equals 0. I'll get the third derivative. That's a 1. Phi prime is also a 1. Sine of 0 is 0. And phi double prime, I just found it to be a 0. Minus 0 times, it doesn't matter what that is. In this case, that's a 0 as well. Plus a 1 phi double prime is a 0 equals 0. And here I get, if I'm not mistaken, let me see really quick. Oh, I'm sorry, that's not phi double prime, that's phi prime. You gotta be careful with those. Phi prime is a 1. So that tells me that phi double prime, triple prime of 0 is actually 1 plus 1, 2, minus 2. So I got y triple prime of 0, which is phi triple prime of 0, that is a negative 2. And one more to go and I'm done. If I take a derivative of this, that will be the fourth derivative, which is what I want, minus the product rule, sine of x phi prime plus cosine of x phi double prime, product rule, cosine of x phi double prime, sine of x phi triple prime, product rule, minus the cosine of x times phi, minus sine of x phi prime, minus sine of x phi prime, plus cosine of x phi double prime equals 0, evaluated at x equals 0 again, and let's see what 0 is out. This is the fourth derivative, that's a 0. Phi double prime is a negative 2. Phi, oh, that can't be right. This was, that was, oh no, that was right, that was derivative of this. Plus 1 times a negative 2 again. Here, sine of 0 is 0, so that's not going to matter. Minus a 1, and phi of 0 was a 0 as well. Minus 0 times, it doesn't matter what that is, that's another 0. And that is 1 times, and phi double prime is a negative 2. And what that means, phi to the fourth, and let's see what we have. We have a minus 2 and a minus 2 and a minus 2. I just need to double check the work. Give me a sec. Okay, again, I found a mistake. These things happen. So, the phi prime is actually a 0. So that's a 0 right there. That was a 0 right there. And that was a 0 right there. So they're all 0. So basically that's just 0. And that means the fourth derivative at 0 is phi to the fourth at 0, and that is 0. Alright, and this is where we're going to stop. We're going to continue the rest in the second video.